In this last section in the chapter, we're going to look at how to solve rational equations. So we've worked with rational expressions, adding them or multiplying them. But now we're going to have an equal sign in there and want to solve the equation. We're going to multiply both sides of the equation by the least common denominator. Most people don't really like working with fractions, and so our first step is going to be to multiply the entire equation by the least common denominator, and that will get rid of the fractions. So then it will become just a normal equation to work with like we've worked with before. It is a valid thing to do to multiply the whole equation by the least common denominator because we can do whatever we want to an equation as long as we're doing it to both sides of the equal sign. So as long as we're multiplying both sides by that least common denominator, we can do that, and that will clear all of the fractions out. And then the last step here says that we want to check for extraneous solutions. We've talked about extraneous solutions before as being a solution that sometimes comes out in the solving of a problem, even though you've done everything right, it pops out an answer that doesn't actually work. Since we're working with fractions, what do you think would make our answer not work? What's a big problem with a fraction? Dividing by 0. So what we're going to look for is, does our answer make us divide by 0? And if it does, it's not actually an answer. So for our first problem here, we want to multiply the entire equation by the least common denominator. What is the least common denominator here? 2x. So we're going to multiply the whole equation by 2x. When I multiply that first fraction by 2x, the x's would cancel, leaving the 4 times 2, which is 8. For the second fraction, the 2's would cancel, which leaves the 5 times the x. And then for the last fraction, the x's would cancel, leaving the negative 11 times 2, or negative 22. So our first step is find the least common denominator and multiply the whole equation by it. Once you've done that, it should turn into just a normal, in this case, linear equation to solve. So then we're going to subtract 8 from both sides and divide by 5 on both sides. Before I box this in as being my answer, I want to double check and make sure that it does not cause me to divide by 0. So if I plug this in for x's, I would have a bottom of negative 6, a bottom of negative 6, no zeros on the bottom. So this is an okay answer. Questions? Go ahead and try this one. Once again, our common denominator is going to be 2x. And multiply the first fraction, the x's cancel, leaving the 3 and the 2, so I get 6. Minus the next one, the 2's cancel, leaving 1 times x. Equals the last one, the x's cancel, leaving 2 times 12. Subtract 6 from both sides. And divide by negative 1. And I get negative 18, which does not make me divide by 0, so that is a good final answer.
So if x is 0, is that one?
On this problem, x being 0 would have been a bad solution. Right. Yep. Right, what is our least common denominator for this equation? X minus 2. That's the only denominator that's there because this is really like 7 over 1. Right? So the only denominator that's there is x minus 2. So that's what we're going to multiply everything by. So in the first fraction, that will cancel the denominator, just leaving 5x. You have to multiply the 7, even though it's not a fraction, we have to multiply every part of the equation so that it stays balanced. So I'm going to multiply that 7 by x minus 2. And then cancels from the bottom of the last one, leaving just the 10. Turned into just a linear equation, but we have a little bit of work to do to solve it. We need to start by distributing. going to combine some like terms. Subtract 7x to get all my x's together. And divide by -2. So I get x is 2. What happens if we plug in 2?
0.
We get 0 on the bottom. 2 minus 2 is 0. We're not allowed to divide by 0. So that means this answer doesn't actually work. And since that's the only answer we got, there is no solution to this problem.
How do you know it's not a solution?
Because the one answer that we got doesn't actually work. Because it would cause us to divide by 0. And dividing by 0 is not allowed.
So when you plug it back in.
Right. When we plug it back in, it causes us to divide by 0.
Oh, I cut over.
Yep, so always check your answers on these to make sure that it doesn't cause you to divide by 0. If it does cause you to divide by 0, it is not really a solution. That's one of those what we call extraneous solutions. We didn't do anything wrong, but it just didn't work out for us. Go ahead and try the next one. The least common denominator here is x plus 1. So when I multiply the first fraction, it cancels the bottom, just leaves the top as 5x. When I multiply the 4, there's nothing to cancel, so I'm going to need to distribute. And then when I multiply the last one, it cancels, just leaving the 5. Make sure you notice that's a minus there between those fractions. Don't lose your negatives. Then I need to distribute the 4 out. Combine some like terms. And subtract a 4x from both sides, which leaves x equals -1. But when I plug a -1 into the equation, -1 plus 1 is 0, gives me a denominator of 0, which is a problem. So there's actually no solution here. Questions? To find a least common denominator, we need to always factor our denominators first when possible. So in the last problems, it wasn't possible to factor any of those denominators, but we need to always check for that as our first thing. So in this problem, we do have a denominator that can factor. That x squared minus 1 is going to become an x plus 1, x minus 1, our subtraction of perfect squares. So then what is our least common denominator in this problem?
X plus 1.
X plus 1 and x minus 1. That covers everything that shows up in the denominators.
Does that mean we can multiply question? So we're gonna have multiple equations, or do we just multiply them?
We're going to multiply the whole thing by that same least common denominator. So when we multiply that first fraction, the x plus 1s would cancel. We're still going to have the top and the x minus 1. When I multiply that next fraction, the whole bottom cancels, leaves just the 12. And don't forget to multiply whole numbers. Even though it's not a fraction, it still needs to be multiplied, just nothing gets to cancel. So I'm going to have the 3 times the x plus 1 times the x minus 1. So we got a lot of foiling to do to start this problem out. So we get 4x squared minus 4x plus x minus 1. When I FOIL together these two, I'm going to get x squared minus 1 because that's where they came from. We got that from factoring an x squared minus 1. So when we FOIL them back out, we're going to get right back to where we started there. And then I need to distribute that 3 through. So I'm going to get 3x squared minus 3. There's some like terms to combine. Get 4x squared minus 3x minus 1. Over on the other side, 3x squared plus 9. This is a quadratic equation because we have those x squareds in there. To solve a quadratic equation, we want everything on the same side set equal to 0. So I'm going to subtract 3x squared and subtract 9 from both sides. So it leaves me with x squared minus 3x minus 10 equals 0. To solve the quadratic, you have a couple options. You could use a quadratic formula if you like that, or this is a factorable quadratic. So when we factor, we're looking for what multiplies to make the last number that adds to make the middle. So what multiplies to make negative 10 that adds to make negative 3. A negative 5 and a positive 2 would multiply to give us negative 10 and add to give us positive 3. The solutions are then what happens when we set each of those factors equal to 0. So we get positive 5 and negative 2. Before we call both of those solutions, we want to make sure that neither one of them causes us a problem. So if I plug in a 5, I would get a denominator of 6 and 24. If I plug in a negative 2, I get a denominator of negative 1 and 3. So everything is fine with both of those. They don't make us divide by 0. Questions? So before finding the least common denominator, factor the denominators when possible. And then this one turned out to be a quadratic. So for a quadratic, get everything on one side set equal to 0, and then either use your quadratic formula or factor to find your solutions. Go ahead and try this one. To find our least common denominator, we first need to factor the denominator that's there. So that's going to become an x plus 2, x minus 2, which that will then be our least common denominator. That covers everything that's there.
When you factor that, what happens to like the normal x numbers?
They would cancel out. Like if we did a FOIL on this, we'd get the x squared, and then our outside would be negative 2x, and the inside would be plus 2x. So they would end up just making 0. When we multiply that first fraction, the x minus 2's will cancel. So I'm going to have the 3x minus 2 times an x plus 2 left over. In that next fraction, the whole bottom cancels, so it leaves just the 6. Plus, multiply the 1, and nothing cancels, so I get 1 times x plus 2 times x minus 2. Then we have some FOILing to do. So I get 3x squared plus 6x, oops, just x, minus 2x minus 4. And then when we FOIL these out, we're going to get x squared minus 4 again, because that's where they came from. Or if you do the full FOIL, then you'll have a plus 2x minus 2x, and they'll cancel each other out. Combine some like terms, so I get 3x squared plus 4x minus 4 and 2 plus x squared. I'm going to subtract an x squared from both sides and also subtract a 2 from both sides so that I get everything on the same side. And what do you notice about all the numbers in this problem?
Reduce them.
They're all even, so we can reduce them down. As long as you're dividing everything in the problem, then that's a valid thing to do. We can do whatever we want to an equation as long as we do it to both sides. So we're dividing both sides by 2. Then to factor this, we're looking for what multiplies to make negative 3 that adds to make positive 2. So it'd be a plus 3 and minus 1. And our solutions are then the opposites of those factors, negative 3 and positive 1. Double check, and neither one of them make us divide by 0, so they are both good solutions. Questions? Yeah.
Why would you divide instead of taking it like on the outside?
You could do that as well. It's going to be exactly the same thing. So at this step, instead of dividing everything by 2, you could write it as 2 times x squared plus 2x minus 3 equals 0, and it turns out exactly the same.
Is this test going on in this group?
In proportions, we cross multiply them. I have this we love proportions thing in there because when I was student teaching, my cooperating teacher was teaching her students how to do proportions, and she did this so cheesy and it just cracked me up. So this is how she tried to help her students remember that we cross multiply fractions when they are equal to each other. Is she would draw a big heart that would connect the things that you multiply. I'm like, oh, sweetie, that's so cheesy. But it cracks me up. So I have that there in the notes in memory of her. As we cross multiply these, I'm going to get 1 times x squared minus x equals 2 times x minus 1. Okay. We multiply the things that are on the diagonals. Distribute then x squared minus x, 2x minus 2. This turned into a quadratic, so I'm going to get everything on one side. Get x squared minus 3x plus 2 equals 0. To factor, we're looking for what multiplies to make positive 2, that adds to make negative 3. So it'd be a negative 2 and a negative 1, which give us solutions of x is 2 or 1. We want to double check those. If I plug a 2 in, I get 4 minus 2, which is fine, and 2 minus 1, which is fine. But if I plug a 1 in, I get 1 minus 1, which is not fine. So 1 does not work, but the 2 does work. Okay, so always check each and every one of your solutions. It's possible they can both be good. It's possible that one could be good. It's possible that neither one of them could be good. So always make sure to double check each and every one of your solutions. Go ahead and try this last example. Okay, so I'm going to begin by cross multiplying. So I'm going to do 1 times x squared plus 4x and 3 times x plus 4. Going to distribute on both sides then. This turned out to be quadratic, so I'm going to get everything on one side by subtracting 3x and subtracting 12. To factor, I'm looking for what multiplies to make negative 12 that adds to make positive 1. So that'd be a positive 4 and negative 3 would add to make positive 1 and multiply to make negative 12. And our solutions are then the opposites of those factors, negative 4 and positive 3. If I test this out, plugging in a negative 4 will cause me to divide by 0 in both of the fractions, so that is a problem. Plugging in 3 is fine, so it's just 3. That's our solution.